Alright, so here is the marble sorter that you just saw being demonstrated. Just wanted to go through and point out a number of things, basically how it was constructed and just how a couple of these things work. There's three main parts to this marble sorter, and I've noticed that really in any marble sorter there's three main parts, and you can break those three main ones into subparts, but relatively three consistently main parts to each marble sorter. Number one is your hopper or your bin, or however you are going to get your marbles into your sorter. Okay, so this is the collector, the hopper, whatever you want to call it. I just made mine out of cardboard because the limited supply Fisher Technic pieces and just the ability to customize the hopper in any way that I can. Okay, so what I wanted the hopper to do was actually be able to dump the marbles in and then just have them roll down and be funneled into the kicker, which is this device right here, which is basically the gateway to get it down to the ramp. So all it is a piece of cardboard fashioned on an inclined plane so that the marbles will then roll down and eventually get trapped behind this kicker door, which is down in here. All right. The kicker is controlled by a motor and then also a potentiometer. The motor turns a gear, which is right here. The motor turns this gear, and this motor also is connected to this cam right here, which acts as the lever that opens and closes and only lets one marble fall through. This gear here talks to or connects with, meshes with this potentiometer, which is what I use to control how far I want this cam to go back and forth. Okay, basically it's that closed loop system where it tells the computer move back to this part, stop, and then move back forward to this number, then stop, and that creates that short little opening for a marble to fall through. So that really encapsulates the hopper part of this system. Okay, relatively easy. It does have its faults. Sometimes marbles will get gummed up in there, but relatively simple to use and has a high percentage of success. Okay, especially I've noticed with this door system here, this kicker as I call it. This is probably one of the better ways to control one marble getting through. So after the kicker opens up, it allows one marble to fall down. Excuse me, after the kicker opens up, it allows one marble to pass down this ramp, which then enters into the second part of the system, which is, I call this the diagnostic area. Okay? And what a lot of people do is they create a system that has multiple diagnostic areas where you're going to run a test to see a yes or no, true and false kind of test to see if it is or is not one type of material. You know, and depending on the type of material, it has different properties, and you can test for those properties. What I found to be good is to actually do all the testing in one area, okay? And this is the diagnostic area. Now, I'll do my best to try and get in here as best as I can and give you a couple close shots, all right? So the marble will actually slide into this diagnostic area here, okay? Now, inside this diagnostic area, we're going to run three tests, okay? The first test that we run, let me see if I can get it from this view. I'm going to move this. The first test that we run is actually done with these two wires right here. You can see one here. I'm not sure if you can see the other one on the other side there, but you see two bare wires just sitting there. That is our continuity test. That we check to see if it is a conductor. Now we have four materials. We have steel, aluminum, wood, and plastic. Those are the four that we use for this class. All right. The aluminum and the steel are both conductors. So if it is a yes, if it passes the conductor test, then it moves into the secondary test. So the primary test is it a conductor? Yes, it is a conductor. All right. From there, if it says it is a conductor, we have this piece down here, which is what everything is actually sitting on. This is the electromagnet. If it is a conductor, the electromagnet will turn on, and this right here stopping everything from falling through is a reed switch. Okay? Now steel will take on magnetic properties when it is by a magnet, basically becomes a magnet itself. Aluminum does not. Okay? So when the magnet turns on, the steel magnet will actually trip the reed switch, telling it, yes, this is a magnet, or detecting magnetic field. The aluminum will not have a magnetic field and therefore not trip the reed switch. Okay? So we run our first test. Is it a conductor? Yes or no? Yes, it is a conductor. Is it magnetic? Yes or no? Yes, it is magnetic. It's steel. No, it's aluminum. So we've therefore already sorted out half of our materials. Okay? Going back to the conductivity test, if it does not pass the conductivity test and it is not a conductor, we then run a transparency test. So if you see right here, we have a bulb, and over here we have a photoresistor. Okay? Now, a plastic marble is translucent, which will let a lot of light straight through it. Okay, and that will read differently on the photoresistor than one that is blocking the light. Okay, one blocking the light has a much different reading. So we can measure those different readings and distinguish the difference between a clear marble or one that is not clear. Okay, so therefore we've distinguished what all four marbles are in one location. This right here is the mechanism that we use for this door. Okay, the reed switch is attached here. So when a marble rolls in, it stops by smacking into the reed switch. And this is connected to this track, and this motor stationary. And then we have a switch here. And what happens is this gate will lift up for a specific amount of time. All right, the gate will lift, and then after it has stopped lifting, it will go back down until this switch is depressed. Okay. So when it's pressed, it goes up, it presses the switch for a timed amount, a specific timed amount, and then it will go back down until this is depressed, and that tells it when to stop. So we actually get the reed switch stopping in the same location every time. All right. Once we've decided or figured out what the material is, we then get into our last portion of the marble sorter. We have the hopper system. We have right here does the...
To the main office, please.
Sorry about that. We have the hopper system. We have the diagnostic system, which is this big old thing here. And then finally we have your bin system. So however you're going to put these in. What I used was a motor on this track right here. This track is fixed into position. This motor will rotate clockwise or counterclockwise and then drive along this right here. Now, I ran out of inputs, and what would be really easy is just to have one switch for each input, which would require 4 switches. I only had 3 inputs, so I had to get a little creative. So I created this system here. I have a switch here, which tells it when it's all the way to the right. I have a switch here, which tells it when this is all the way to the left. And then I have one switch right here, okay, and these two guys here and here will actually trip the switch as it goes by. All right, so you see that motion right there. So I can tell if it's lined up with bins, bin 1, bin 2, bin 3, and then bin 4 is when this one back here is being smacked into again. Okay, see that? Bin 4. And then I just wrote a program which would allow me to do that. And again, what will happen is it'll do the diagnostic. Once it has it figured out, it will engage this motor, move this into place. It'll stop at the appropriate bin. The gate will lift, the ball will be dispensed. This will go back down until this is again depressed. Then the kicker will let another marble through, and it will go through the entire process until all the marbles are sorted.